All right, we're here with Bob Lantz, the creator of Mininet, which I think all the students in the class have been using, and I think we all love. And Bob's at ON.Lab, and we're going to talk today a little bit about past, present, and future of Mininet. So thanks, Bob, for joining us.
Yeah, that sounds great. Well, I hope it works well for you, and don't hesitate to. Oh, is it still working? Let's see. Google loves to give me these errors, but hopefully you can still hear me.
I can still hear you. You're there.
Yeah,
Yeah.
hopefully it's working well in the class, and don't hesitate to give feedback. The best place to give that, of course, is the mailing list. Although you can also email me personally. And another great place to give feedback is if there are actual bugs, to file them on GitHub, and also to send pull requests. Even better if you find and fix bugs. So yeah, so look forward to to hearing people. I always love to hear from people who are using Mininet for all sorts of things, and it's very interesting. I don't necessarily have a lot of visibility into what people do with Mininet. Like Mininet doesn't track you and tell me what you're doing with it. That perhaps would be interesting for me to know, but I would hate that, so I would never do that to anyone. So I just rely on people sort of talking to me, and also looking at papers, and seeing, oh, this refers to Mininet, or use Mininet for an experiment, or looking at, or finding out about classes, but I don't necessarily, not necessarily in the loop. So it's always really interesting to hear what people are doing with Mininet and what they think about it.
No, definitely. I mean, we're huge fans, huge fans. So thanks. Thank you, first of all. um, so I actually wanted to ask, how did Mininet get started? Like, I mean, you basically created it some time ago, and the rest is history. But how did it all begin?
Yeah, righto. So a couple of interesting things. So so I was working on OpenFlow at Stanford. So back in the day, where we would sit in these, for OpenFlow, from its origin up to OpenFlow 1.1, we would have these meetings talking about OpenFlow and what belongs in the protocol and various things, and how, and sort of evolving the protocol and figuring out what should be in the first version of it. And in one of these meetings, one of my colleagues, Yanis Yukumis, was sitting there, and his laptop was going into overdrive, and sort of sounded like a jet engine, and is sort of radiating. I'm like, Yanis, what are you doing? He's like, well, I'm doing OpenFlow on my laptop. He had a test network set up on his laptop. I'm like, wow, you must have a really huge OpenFlow network. He's like, well, no, actually, it's about the smallest network you can imagine. I have one host in a VM, another host in a VM, an OpenFlow switch in another VM, and then an OpenFlow controller in another VM. So it's kind of the smallest OpenFlow network you could imagine. But it was really ridiculously taxing the resources of his laptop. And it was clear at that point that we were really doing it wrong. And at the time, I was working at Arista, and one of my colleagues, Arista Networks, and one of my colleagues there, Eric Biederman, is responsible for network namespaces, basically some of the a la carte virtualization features of Linux kernel. He actually implemented network namespaces and worked on other namespaces as well and merged them in. And Arista used network namespaces to test hardware, actually. You could have a device under test in the lab and have it connected to the control plane software running in your laptop, and have all the interfaces tunnel. It was a really neat setup. But it occurred to me that it would be a really great idea to use this for network emulation and for OpenFlow development. I guess another thing to think about is, well, I guess another thing I'll say is how I got into networking. I just walked into this seminar at Stanford. I think it was the EE380 Computer Systems Seminar, and Nick McKeon was giving a lecture there. And I wasn't really a networking person at all. I was kind of an operating systems person. I was working on my dissertation, was really in computer architecture and architectural simulation. And he made some really interesting comments, which is that he said, computer networks are like hardware without an operating system. And I was like, really? Is that really true? Because operating systems are really good. They give you all these good things. They give you useful abstractions. They give you a nice API for programming things. They give you resource management and scheduling. They give you user groups and permissions and multiple administrative domains. All these really awesome things that we know and love with servers. And do switches really work differently? And of course, when I started investigating how switches worked and ended up working at a switch company, I found that, yeah, the operating systems were all in the box, and they were really kind of primitive and didn't do a lot of the things that you would really want. want your network to do and really want an operating system for networks to do. So I really thought that creating a network operating system was a really good thing that needed to happen and something that was really missing in the world. And the problem is, of course, when you're developing any sort of software system, be it system software, application software, you need a development platform. And so I really created Mininet as a development platform for that network operating system, and to solve that terrible, terrible problem caused by heavyweight virtualization. And fortunately, Linux has lightweight virtualization, a la carte virtualization, just enough virtualization, where you just virtualize the minimum amount that you need. And so by doing that, Mininet was able to get drastically improved scalability on a single laptop compared to what you could do with heavyweight virtualization. And the same thing's even true compared to, sort of heavyweight containers and LXC, which is another container virtualization system, or user mode Linux. There are all these virtualization systems, some of them which use different parts of Linux. But the idea of Mininet is you just have a process connect with basically an IP address, or an Ethernet interface, and that's pretty much it. And that's all you need to do networking. So that's kind of the origin of Mininet. And so that's how. So I demoed it to the sort of OpenFlow software architecture sort of working group. We were just sort of meeting every week, and one of the people there was Brandon Heller, who I'd been talking to about this thing. We should really use network namespaces to do OpenFlow development. He's like, it's like, oh, what is this? And then I demoed it. He's like, oh yeah, this is great. We really need it. And so Brandon sort of immediately joined the Mininet project, and is really responsible for turning it from a research, for helping to really drive me to turn it into this, and also to contribute code himself and really join the project to basically turn this from a research prototype and demo to something that kind of anybody in the world can use for research, teaching, in software development or controller development in industry as well.
Yeah, that's interesting. I mean, it's interesting that you mentioned these like sort of variety of container technologies, and now I think basically, Docker seems to be all the rage, which is basically just LXC containers with a, nice, fancy, usable interface. And I think one of the cool things about Mininet is not only the technology, but also how easy it is to use. And I'm wondering what you make of this sort of the whole Docker movement, and if there are implications for Mininet there. I mean, both are quite easy to use, but they're using totally different technology, or not totally different, but a little bit different.
Yeah, I mean, at the core, they're using. I mean, everything's built on the same thing, right? It's all built on Linux. So, and it's all built on the Linux container architecture, which is a little bit. I mean, perhaps bears a bit of explanation, which is that Linux has this a la carte virtualization system known as variously as containers or as namespaces. And really namespaces, well, there are a couple features. Namespaces is one of them, control groups is sort of another. But basically, if you look back to operating systems since perhaps almost as long as we can remember, operating systems have always had this kind of virtualization technology called like processes, that give you the illusion that you own the whole machine, right? That you can use as much memory as you want, well, hopefully until you run out, or until you run out of virtual memory, and you don't have to worry that there are other people using the CPU unless there's interference, because there's really not enough resources to go around. And so processes are not just a virtualization; they're actually an abstraction. But even so, they virtualize the CPU, and we have virtual memory in operating systems. And so what Linux has really done, and actually derived probably from other operating systems like FreeBSD had virtual Ethernet pairs and had jails, and Solaris had zones. Basically, there's this sort of operating system level virtualization technology, which Linux has taken and sliced up, so you can say, well, if I want a network interface attached to my process, I can do that. If I want a different set of users and groups attached to a process, I can do that too. So there are all these namespaces in Linux. And it's a really great system because it allows you to build all kinds of virtualization solutions, from like kind of a sort of heavyweight container solution, sort of like LXC and Docker, where you get something that's basically a full virtual machine with its own file system, maybe, or perhaps a union file system in the case of Docker. But it really acts just like a server, and the only difference is you're just sharing the same kernel. To something like Mininet, where you share everything except every process gets its own kind of IP address and Ethernet interface, and basically IP and Ethernet stack is what's virtualized in that case, and that's what you need to do networking. But all this stuff is useful, and so it's sort of like how you slice it and how you bundle it. And so I think I like easy to use. As you noted, Docker's easy to use, and they have good tutorials, sort of good good website. They have a lot of sort of, I mean, in some sense, good sort of marketing as well as product development. I think has helped out a lot. And containers are good. Like I'm gonna preach. I mean, I think we're all on team container here. So on the other hand, it's not my goal immediately for like Mininet to replace OpenStack, even though it kind of can do the same thing. I mean, you said this in one of your lectures, which I think was brilliant. You said, we've talked about network virtualization. Mininet's a network virtualization system. It absolutely is. I mean, I've known this for a while, but you sort of crystallized it and said it very clearly, which I really appreciate. And it turns out you can do OpenStacky type things with Mininet, although probably you don't want to run your infrastructure on it, but you could. But Mininet obviously doesn't have the things like, most notably, OpenStack's Keystone authentication database and multiple administrative things. Mininet kind of ignores security, which I think I should warn everybody about. You probably don't want to usually connect your Mininet network to the internet at large. If you do, you should be careful about that. Or at least only connect a virtual machine that you don't care if it's owned. You can just start up another one on your laptop or a EC2.
Right. Throw it away when you're done, basically.
Yeah. So I mean, Docker's kind of more in the OpenStack sort of space, but there is this other really irritating problem with Linux, which is kind of application packaging is so terrible.
Absolutely. Yeah.
Can you hear me?
Yes.
Yeah, great. Yeah. So we have RPMs and debs and all this stuff, and it's like DLL hell on Windows that whenever you pull in something, you have to pull in 20 other packages that change all your libraries, and you need all this stuff, and it's there's no consistent ABI in Linux the way there is on Mac OS or Windows, where for the most part I can have an app from a Win32 app from the 1990s, and I can still run it on Windows 7, and I can have a Mac OS 10 app from the early 2000s, and I could probably still run it on Mac OS Yosemite, even though Apple's sort of less backward compatible than Microsoft is for the most part. And but Linux, you're all out of luck. So as a result, virtualization technologies that wrap the whole environment up around an application and deploy an application sort of as a VM have sort of, I think that's one of the things that's driven it on Linux. On the Windows side, it's a sort of lack of isolation and lack of security that's kind of driven virtualization technology. That I don't really trust Windows to isolate my mail server from my payroll server from my web server, and so I want to run them all in separate virtual machines. That's kind of why I think a big reason why people do virtualization on Windows. So yeah, so on Linux, I think Docker, you see these Docker images of like, oh, we shipped a version Onos that comes as a Docker image, and why is that? It's like, well, because Onos is a pain to install, and because it needs all these libraries, it's, and the thing is,
I've pulled the Onos Docker image, in fact.
Yeah. So it's my goal to make that go away. I mean, on multiple fronts, to make it not necessary, to make it so you can just, double click a jar, and it's a Java program to run a simple run Onos on the Onos side, and on the Mininet side to make it possible for Mininet to have an object that looks more like a server. And so this is one thing I'm adding to Mininet is, make it a little bit, make Mininet host, or add a Mininet host object that is slightly heavier weight than the Mininet host that you can run SSH in, that has its own process namespace, and doesn't actually uses the overlay file system, so that you can remove files and add files without messing with your underlying file system. So that's something that looks more like Docker. Also, somebody, Gregory Yee, who is responsible for doing most of Mininet's mini-edit GUI, also created a Docker object for Mininet. So we may integrate that in as possible. But I sort of want to discourage people from using Docker and Mininet for the most part, because I think it's sort of more overhead than you need. It's the same reason why I want to discourage people from, I want to start up 10 virtual machines and connect them to Mininet. I mean, that's not what Mininet was designed to do. That's going backward, not forward. It's making it's kind of making the development process sort of making your run, edit, compile, debug loop for your SDN application harder, bigger, fatter, and slower. So you really don't want that.
Right. You really want this sort of lean emulator, if you will.
Yeah. But if you need to run Windows, if you need to run BSD, then you need real virtualization for that. So you need full system virtualization.
Actually, yeah, I mean, it's interesting your comments about like the relationship of Mininet with OpenStack and other things, and also coming back to what you said at the very beginning, you don't really know who's using Mininet, but what I guess what's your sense of? I mean, I certainly use it a lot in research and teaching and so forth. Are you familiar with people using it in sort of commercial production environments? And
Oh yeah, yeah, definitely. I mean, so I don't know, like at ONS, the Open Networking Summit was what last week or so, and like, we'll ask people like, how many people have heard of Mininet or use Mininet, and like everybody in the room raises their hand. And this is largely, Silicon Valley industry people, and people from networking companies, people from cloud companies, people from app companies, people just from Silicon Valley. So I don't have a lot of visibility into that. And whenever I talk to people like, I talk to people at Cisco and CME, they're like, oh yeah, we're using Mininet, we love it. I'm like, so what are you doing with it? Oh no, we can't tell you. So I don't necessarily know what they're doing, right?
I think there are other organizations that are probably using it too that can't tell you what they're doing.
Oh yeah, yeah, exactly. I have no idea. But pretty much, everyone I talk to in Silicon Valley who does SDN has heard of Mininet. And Mininet's not necessarily the right tool for all, jobs in SDN, but I see a lot of uptake, and I can tell you what it's used for. First, pretty much every controller platform that I'm familiar with, so, Open Daylight, Floodlight, Ryu, Pox, etc. Since Knox, since Mininet has existed, has used Mininet for development and testing. And so pretty much every controller is sort of built using Mininet, which is kind of gratifying because that's the purpose of Mininet that I really had in mind, is that it's a development platform to enable us to create an SDN operating system. Now, most controller platforms aren't quite an operating system yet. They're more like protocol wrappers, or we're in a really primitive operating system era for SDN. But that's its purpose, to be a platform for development. So people are using it for controller development, and also for application development, of course, on top of controllers, and also for testing.
Yep.
It's kind of a convenient way to spin up a virtual network for end-to-end system testing.
Yes.
And one thing that is important to me with Mininet is this idea of parameterization and parameterized topologies. And to say, well, I want to run my app over 20 different topologies and with all these different, and just change a few numbers, and I can say, oh, well, now my mesh, instead of being 10 by 10, is 20 by 20, or my tree depth has changed, or the number of interconnection links has changed.
Yeah, I really like the way that you've done that in Mininet, and just the programmatic API makes it, I mean, quite easy to do that. And actually, as you know from the course, like we have students play with that, like generating different topologies through the API. I think it's quite handy.
That's kind of one of my other kind of design philosophy thoughts on Mininet and things in general, which is that flat configurations are, in XML or JSON or whatever, or comma separated values are okay, and it's nice to have things. It's nice to have like a set of existing topologies, like, oh, this is AT&T's network, we want to assimilate it. That's great, but I really think that Python as a configuration language is much more powerful, because instead of having to write 10,000 lines of configuration, I use a for loop.
Yep. Yep.
So yeah, it's
good old for loop.
For loop. Yeah, it's like, I don't know. It's like
functions.
First order,
it's amazing. You can configure your network using a function. It's
exactly. I mean,
it's just a concept, but
it's what it's all about, right? Taking something that used to be really painful and manual and making it automated and done by software.
Yeah, definitely. I wanted to ask you a little bit about what's kind of going on with, I mean, you mentioned like the nice aspects of Mininet that make it scalable. And I know there's been a little bit of work on sort of running Mininet over a cluster. At least I've seen some stuff on GitHub about that. I haven't tried to run it myself. What's the kind of status of that as far as like, really kind of scaling it out beyond one machine? You think that's feasible, or is that, something that could happen?
Yeah. So since day one, like if you look in the Mininet source code, it says, it actually mentions, from, first version of Mininet, we sort of, mentioned, this mythical, like, well, not entirely mythical, Mininet cluster edition. And I say, well, I even had some comments like, oh, I think these objects could be made proxy objects for, remote switches and hosts on other servers and things like that. And it turns out, if we go back to, I don't know, 2012, I guess Vitaly Antonenko from ARCCN in Moscow, who I'll probably never see again because of politics, but he's a great guy. Basically, he was working on propagation of malware. That was his working on it. That was his area of research for his graduate study, and he made a network on multiple servers consisting of like 30,000 hosts connected by Mininet over multiple servers, and he wrote a wrapper script, a cluster edition to put this together. So we've had this sort of thing for a long time. Also, Philip Veta, who's been on the mailing list, has made a cluster version of Mininet called Maxinet. It's probably the most mature cluster edition of Mininet at this point. So I'm inspired by all this stuff, and I think that clustering should be part of Mininet proper. And so since, I don't know, the last or second to last version of Mininet, we've had experimental cluster support in Mininet that allows you to distribute a Mininet simulation or a Mininet experiment across multiple servers in a really kind of simple way by just having a cluster option. Cluster, localhost, machine X and machine Y, and it'll just like distribute it over the cluster just as a command line argument. So I'm really into making it as easy as possible and sort of making it so that it's not as complicated to set up a Mininet cluster as it is to set up an Emulab cluster test bed. So I'm kind of into ad hoc clustering. So we have this experimental cluster feature, which is in there and it works, but it doesn't address the issue of I want a large simulation to start up very quickly.
Right.
What it does give you is it gives you the ability to use more resources, to have like higher bandwidth links, to have like servers that have more memory, more megahertz, more gigahertz, more gigabytes, or megahertz, megabytes if you're slicing it, shall we say?
Yeah.
And sort of faster interconnect, more gigabit links because I've distributed it across. So in terms of sort of resource scalability, it works pretty well, but it also it has some bad scaling characteristics in terms of it actually creates too many processes as it is, and also is not as fast to start up as I'd like. So the thing I'm working on for the next month or so is completely revamping Cluster Edition, and I'm going to demo it.
Oh, cool. So that's like the top line item right now for you.
Yeah, that's what I'm working on because the demo is at SIGCON next.
Oh, awesome!
Month.
Awesome.
So,
I'll see you there. I'm psyched for this demo.
So yeah, so you can come and hopefully I'll have something. I'll have a demo of whatever there is, but hopefully it'll be kind of
hopefully
interesting.
It'll be this.
What?
Hopefully it'll be this. Yeah.
Yeah. So that's kind of what you'd call scale out performance. And in addition to that, I'm working on scale-up performance, both on small machines and on bigger machines. And so one thing I've done recently is, you may be aware that sort of OVS DB gets slower and slower the more links and the more switches you put into it. And that is reflected in Mininet. The more OVS switches you have by default on the same OVS DB, the slower and slower it gets. So like up to 50 or 60 looks pretty good, like 60 to 70, 70 to 80. And it's because every time you do it, even though the commands are batched, every time you do an OVS vskittle command, it has to load the same database, and it's the way OVSDB works.
Yikes.
So I have a version of the OVS switch that uses multiple OVSDBs, and so that really improves the startup time significantly. So I can make a 32 by 32 torus, so that's like 1,000 switches, 1,000 hosts, 5,000 links. It'll come up in like a minute and a half on my laptop.
Wow.
It's not as fast as I'd like, but it's certainly doable. And the nice thing about that is that I feel I'm a little bit ahead of the game because every existing OpenFlow controller I've tried that configuration with tends to sort of melt down and perform very poorly.
Yeah, if you can keep ahead of the controller capabilities,
Right. So I figure as long as I'm ahead of the controllers on the laptop, that's a pretty good place to be. But I still want to move. So that's scale up on a laptop. Still want to do better scale up on Big Iron and better scale up across a cluster as well. So working on all those things. So batch mode is one thing. Batch startup is one thing I added to Mininet to improve performance on a laptop, actually on a laptop or any server, just single system performance, and then also this multi-OVSDB to sort of get around this OVS issue of the more switches you have, the worse OVS vskittle performs because of loading the database. And it's also possible, of course, if you don't use OVS, if you use some other switch like the Stanford reference switch or the CPQD switch, it doesn't have those issues, and
interesting.
Although it does use 2 processors per switch, so 2 processors per switch. So you may running
Different scaling issues in that case.
So yeah, I mean, there is no free lunch.
Right.
So, I mean, we run into this in CS244 at Stanford, which is the graduate networking course, where people, which you should all check out, by the way, the blog for the course, which is the Reproducing Network Research blog, wordpress.com blog, which I'm sure you've checked out.
I'll link it from the course pages. That blog is awesome.
Great, yeah. So it's basically all the, trying to bridge the gap between a PDF and actual sort of networking research and experimental practice by reading the PDF and trying to reproduce the experiment. And what's really interesting is one, how many of the results are good. That's kind of encouraging for us as a discipline that it's not completely bogus.
I feel a little better.
Yeah. But what's also interesting is the ones that don't work and why they're not successful in reproducing them. Sometimes there are bugs in Mininet. The main reason, and that's good because we find them and fix them. Sometimes they're sort of micro-level behavior that's kind of issues that aren't things that aren't well suited to reproduction on a sort of time slicing emulator. Although that's very, very rare, so I haven't really run into that. But most of the time, it's the experimental configuration where someone's like, oh, I have this, this fat tree, and I want 64, 10 gigabyte links or 10 gigabit links, right? And you're not going to get that out of your poor laptop or netbook.
Yeah. We've run into the timing issues, by the way, in the course because people running it on a wide variety of hardware with different capabilities, and some of our auto grader checks are timing based, and we had to sort of relax the ranges that we looked for just because people are running on some fairly vintage equipment in some cases.
Yeah, well, the good news is Mininet can scale down. Like I've been running it on a Raspberry Pi.
Oh, nice.
Which I love because
that's cool.
I sort of talked to Phil Levis about this, and he was really into the idea that sort of two ideas. One is that when you do network development, it's really nice to have something that feels like a piece of hardware that you can plug into. And also, it's nice to be able to plug into the real internet and get random packets. And
real traffic.
Dangerous for Mininet. But the idea with the Pi is you can make maybe a network in a box that has this virtual network in a box, but also has Ethernet ports, so you can plug it into stuff. And so I think that's kind of an interesting application. Although obviously it's not a particularly high performance setup. But yeah, one thing that I haven't done as much of that I would really appreciate more contribution from people like you who are interested in performance experiments and your grad students is continuing to sort of push the performance accuracy of container-based emulation and things like Mininet. And so Brandon Heller's PhD thesis had some really kind of good ideas in terms of this idea of network invariance, of things that should always be true in your experiment. And you sort of can monitor these, and whenever they're not true, you probably know that your experiment has gone bad. Whenever they are true, you don't know that your experiment is good, but at least you have more confidence that it.
Yeah. Nice thought.
And so I prototyped. Brandon and I and Vimal and Nikhil prototyped monitoring software for Mininet, but it's kind of a separate thing and has not necessarily been integrated into the Mininet core. So just I don't know. I definitely appreciate more people looking at that and commenting on it and looking at contributions and ways to answer the question, which I pose as emulators. Can we trust them?
Yeah, no, that's a great question. I mean, hopefully more than simulators. I think that's definitely why we're seeing a lot more of it.
Well, it's kind of interesting. Simulators have this wonderful notion of virtual time.
Yes.
And virtual time is a beautiful thing because you can do an infinite amount of computation between clock cycles.
Yep.
Whereas with an emulator, it works in real time, which is nice because you may have a real human or the real internet connected to it, and it actually works. Whereas, it's fine if your wave propagation equation, calculates, what your Wi-Fi data rate would be, and you find it out tomorrow because it takes 24 hours to compute. But the idea that you can interact with something in real time with real applications and real traffic and real people is really neat. But virtual time is really very, very useful, and I think simulators can up their game. I mean, my graduate work was in complete machine simulation, and so one thing that I find that a lot of simulations and simulator developers omit is they don't necessarily run all the same code in terms of operating system code, library code, real application code, and switch code that you run in real hardware.
That's just it. Yeah.
That makes it less realistic. And of course, that's an advantage of Mininet because we just run the real code. It's really cool. But it's good for simulators to do that too. Like I really believe that complete machine simulation is a good thing.
Yes.
And, I want to see people connect network simulators to complete machine hardware simulators to get more accurate results that and preserve this really nice property of virtual time. Another neat thing about virtual time is you can potentially run faster than real time, which is really nice as well. So you don't have to wait a week to find out what a week of your traffic results would be. So
good point. Yeah, definitely.
Although you can also do time dilation in Mininet. That's another interesting thing. So simulators in general, emulators in general can do this, where they sort of have this notion of virtual clocks that are locked to the real-time clock in terms of some multiple. Like real-time might progress slower or faster than virtual time.
Yeah.
Some multiple, and there are a bunch of papers on this. I guess die-cast times slice time, various things. We did it in Mininet. Vimmel used KVM to basically run Mininet in a virtual machine whose clock would be different, would be sort of a multiple of real time, and that turned out to work really well. That we sort of get this that all of a sudden you could take 10 seconds of real time to simulate, or 10 seconds of real time to simulate 1 second of virtual time, and all your links can run, and your CPUs and everything can run 10 times faster. So that's a good approach. Someone else did the same thing, but using the Linux kernel and something closer to containers, and presented that in SOSR. And what I'd really love to see, although it remains to be seen what the use cases are for this, is an expansion of the namespace subsystem of Linux to include clock namespaces. This idea that you could have virtual clocks that vary from the real-time clock in some way. And they didn't quite do it that way, but I think clock namespaces are a winning idea. It's obviously great for Mininet, but could also be used for other things like testing various subsystems in Linux to determine how they perform on hardware of varying speeds.
Sure.
So things like drivers, things like real-time characteristics, things like anything that's timing sensitive in the operating system or applications. Potentially, this clock namespaces idea could be used to test it. So
interesting. Yeah.
I'm not particularly optimistic that this will happen in the near future, but I think it's a good concept that potentially has legs. And maybe I can also bug Eric Biederman about it. Say, yeah, why don't we have clock namespaces? I want clock namespaces.
Yeah. That's a cool idea. So actually, just to close, one. I mean, you've talked a lot about like cool new features, and I thought I'd ask you, since Mininet is I mean, you were to sort of round it out at the beginning, you were saying you take bug reports, pull requests, contributions of all kinds, and I thought I'd ask you, what's the most interesting or sort of I mean, I'm sure you get a lot of interesting pull requests, but what's sort of the most impressive pull request that you've got where you're like, oh, I hadn't thought of that, and that's really cool, and thank you for that.
So it's kind of rare that I've been surprised, although sometimes bugs surprise me. I'm like,
right.
That won't work. So those are always great. I say bug fixes and reports are the most surprising ones. Like, oh yeah. I haven't gotten as many pull requests as I would like. The ones.
So for all the students listening who have complaints about Mininet things, send pull requests.
Yeah.
So,
but I'd say the ones I'm happiest with are ones that are sort of, kind of well written, good code, and people have thought it out well. So I liked. I mean, some people who are just kind of great people send me good pull requests. So I always like that. It's like Andrew Ferguson, who is at Brown and now is somewhere else like Australia or Google. Sent me fixes for the TC subsystem for link bandwidth and latency, and so that was really nice because that's something that is really kind of has a nasty command line interface, and the semantics are complicated, and all that stuff. So I was really quite impressed that, like, I didn't want to mess with it either because it was a pain, right? so this was great, right? Somebody who's really smart and, like, figures this stuff out and fixes it. That was really beautiful. Also, Rich Lane of Big Switch made some changes to MNexec, which weren't exactly what I would have done, but I merged them in, and the thing I liked about them is they were correct. So,
yeah, always good.
That was good, and I sort of modified MNexec to be more like NSEnter, or more like Docker. Well, kind of stuff more like Docker LXC, in that you can sort of specify all the different namespaces. But I can't get rid of, as an interesting aside, I can't get rid of MNexec just yet because for two reasons. One is that Unshare and NSEnter aren't part of many Linux distributions, and two is that they don't fully attach to a container in terms of attaching to the CPU control group, which is very important for performance isolation.
Cool.
So that's sort of an issue, but I'd say that the most significant probably contribution to Mininet so far has got to be I guess Gregory Yee's expansions to Mininet. Mininet for a long time is one of these examples of if you build it, they will not come. I made this basic GUI for Mininet, and I was like, okay, I've done all the framework. Now, I hope somebody else will add to it and do something useful. Because like the groundwork has been done. You just need to sort of pull in additional features. And so for a long time, nobody did anything until this one guy said, "Oh, this is good," and like added a bunch of stuff to it. So I was really, really happy with that. With adding features to Mininet. So check out Mininet if you haven't already. It's really quite neat. Like, it's always exciting to me to have a network editor. I mean, Immunes and Core have something similar, incidentally, as other container-based emulators. But it's really neat to be able to draw out a network and then click a run button and have.
Oh, that's neat. Yeah, I haven't seen that. I'll definitely check that out. It sounds really a great tool.
Yeah, there's certainly, there's certainly one thing that I've observed is that Mininet's usability can definitely be improved, and so this is more of kind of a packaging issue. But make it easier, particularly for Windows users who are like, oh, I don't have X11, I don't have SSH, and those are sort of barriers to entry. And so probably shipping a VM with the GUI built in, so you can just type in the VM console. Then you don't have to worry about X11 and SSH. You can just use it. That's one thing that we'd probably like to do in terms of packaging.
Makes sense. Cool. Well, thanks much, Bob.
Oh yeah. So I thought I'd have trouble filling this, and I just can keep talking forever. But
no, this is great. We're gonna have to do another one of these, I think.
Oh yeah, I'd be happy to anytime.
Yeah, this is great, and I think basically you've got 50,000 enrolled students in this class who know your tool by name, and now they know you. So this is super
fantastic. Great. Well, good to meet you all. I just have to say, like, wherever you go, whatever you may do, it's really great to have a network on your laptop. And so I hope it's useful. And I want to thank you also for using Mininet and for your feedback, and also for participating in our Mininet tutorial for teaching computer networking with Mininet last year. So I really believe greatly in building tools that really help students and researchers sort of change the world with nothing more than a laptop. So
yeah, I think you've really changed the game. I mean, you definitely changed how I approach networking as well. So that's really you've done some quite remarkable stuff.
Oh, awesome. Well, and I also love your lectures when you talk about Mininet. It's great stuff. So I'm happy to link to any of those on the Mininet page.
Sweet.
So yeah, and I should really check out more of your course. Just as a comment on it, one thing I just want to give you a little bit of feedback. That one thing I really love about the course is that you seem to have a great vision of SDN as applying not only to the control plane, but also to the data plane.
Yes.
So, I mean, when I took your course, you talked about Click. I don't know if you'd talk about P4 or about...
Yep, we did a whole bunch
of things. Yeah. But basically, like, all NFV it's just SDN for the data plane. That's all it is. Yep. So it's a great perspective, and I want to hear more people say that, and hopefully people in your class will really get that message too.
Yeah, I think we're working on it. So thanks much, Bob.
So thanks a lot, Nick. I hope to collaborate more with you in the future, and I'm happy to chat anytime as well.
Cool, thanks.